Welcome to Everything STEAM. I'm your host, Sam Stanford. As a physicist and structural engineer in training with Jacobs Engineering, I've made many connections with some bright individuals who are either working, studying, or self-taught and passionate about our particular topics of discussion. So this episode features landslides. And landslides can occur almost everywhere. But why? In this episode, our esteemed returning guest, Sebastian Lobo-Guerrero, describes what landslides are, how they occur, and what effects it has on our natural environment and our society. Oh, and of course, Sebastian mentions some really cool remediation and prevention tactics. But if you're unfamiliar, Sebastian has his PhD and practices professionally as a geotechnical project manager and laboratory manager at Aegis Incorporated. In 2020, Sebastian was named as the Civil Engineer of the Year in the Pittsburgh chapter of the American Society of Civil Engineers and has many esteemed accolades. It's hard not to mention that he has over 100 published papers and presentations all over the world on geotechnical engineering and has 21 years of experience and counting. He is also the former chair of the Pittsburgh American Society of Civil Engineers Geo Institute and the former director of the ASCE Pittsburgh section. Right after our last recording in 2021, Sebastian earned another distinguished award, being the American Society of Civil Engineers Lifetime Achievement Award. Now that's a big-time recognition. So now that you've been introduced to the topic of this show and my dear friend Sebastian, we're going to head into our first commercial break. But hang around, because when we come back, Sebastian and I are going to be sliding into an intro in landslides as well as a commemoration of the great Dr. Vallejo. Stay tuned. Well, Sebastian, welcome back to the show. I know it's a new show now. It used to be at Woke Talk Podcast whenever you were here. You were on the 5th episode, right? When we were talking about sinking cities. So
Yes.
welcome back.
No, thank you. It's always cool to be back. And yeah, I love the new name. I love everything that has happened in the last year. I think we talked last time on air in July, maybe, or August of last year. It was middle of the summer. So yeah, a lot of good stuff. And yeah, it's great to connect back.
Absolutely. So how's life been treating you? What's been going on with you?
Good. I mean, I think keep doing the same kind of projects. Here in Pittsburgh, a lot of landslides that we're going to talk about today. Other interesting projects in Alcosan, which is the local wastewater plant, doing a lot of piles, foundations there, also foundations for bridges, and also extremely excited that now conferences also have kind of resumed to normal. So traveling a lot these days, which I always like, to different events. Still being very careful as much as I can, right? But it definitely is nice to go back to to these kind of things and learning opportunities. So
didn't you just go back to Colombia recently?
Yes. I was there about I don't know, probably like a month ago. And then I was in Charlotte, and then I was in Atlantic City, New Jersey for another conference. And yeah,
nice.
Traveling. I'm doing one conference a week, I think, in average. So between virtual and in person, which is great, because I mean, I do love that, right? I mean, going and networking and seeing people and sharing what I know, and also learning a lot, because that's also when you learn, right? When you go to those things and see others, that's in the discussions. I think that's the part that I like the most.
Oh, absolutely. And aren't you from Bogota, Colombia? Or is that just because I know we talked about that quite heavily in the Sinking Cities episode. I don't know if that's actually where you originally
Yes. No, I am from Bogota. Born and raised there, and lived there until I was 22 years old. Then came to Pittsburgh. And now it's half of my life. Hard to believe, but half in Bogota, half in Pittsburgh. So
that's awesome. So today we're going to be doing, so this first segment we're going to be talking about, well, first of all, we're going to be doing a dedication portion to Dr. Vallejo, like literally a legend at the University of Pittsburgh. Unfortunately, in my short term at Pitt, I had no contact with Dr. Vallejo, which is quite sad, but I've heard such profound things from everyone, which is great. So I guess let me jump over on this slide here, and maybe you could talk about Dr. Vallejo, because I know you have really close ties to him, right?
Yes. And that's probably really the only sad thing that has happened in the last few months. He passed away very recently. he was in Colombia. He retired from the University of Pittsburgh about 2 years ago, and he was traveling around. He had a property in Colombia, and he was spending time there. He ended up going to the hospital. He was not feeling good, and they discovered a cancer, and it was in a very advanced stage. So I was lucky enough that I was able to see him in Colombia, like about a month ago that I say. And I did have my final conversations with him. Then he came back to Pittsburgh and unfortunately passed away like 3 days after coming back. Yeah, so I mean, it is very sad, and but at the same time, I guess we're gonna focus not on the sad part, but more on the good side, which is what he did, right? And what he meant for many of us. That's really what we want to do today. Like a short story, I met Dr. Vallejo more than 20 years ago when I was in Colombia. He's the only reason that I'm in Pittsburgh. I mean, he's the person that brought me here. I mean, we could have a whole episode about him, so I'm gonna try to just hit on the highlights. But I met him while I was doing a slope stability class in Colombia. I discovered slope stability as something that I like since I was a kid. I mean, my dad was a contractor, and I love going to different construction sites, highway construction, and seeing the slopes. I don't think at that time I identified what was slope stability, but I just love these rock cuts and things like that. You probably have seen a picture of me as a kid, like with my camera taking pictures of those. But anyway, so once I started college and I kind of started learning what was geotech, because initially I didn't know what geotech was. I thought I was going to be construction management. That's what my dad used to do. But I discovered geotech, and I ended up taking a class, which was, so this is the spring of 2001. I ended up taking a class that was called slope stability, and it was an introduction to slope stability. And Dr. Vallejo was going to Colombia during the summer to teach a class that was called Advanced Slope Stability. So I ended up taking that class, and it's a story, as I said, it's a story for another podcast, because it's too much. I mean, like, I was not even supposed to take that class, but at the end, and he was not even supposed to teach that class. It was somebody else from Georgia Tech that was supposed to go. This person canceled at the last minute because the Colombia situation at that time was not the safest place. So this person canceled, and then they kind of contact Dr. Vallejo, because the professors back in Colombia thought, well, he's from Colombia, so he should have no problem coming to Colombia, right? And he did. And then I was not even supposed to take that class, because it was a summer class, 2001. But then this is true, man, and there is no shame on saying it. The professors really wanted to be there, but it was a very expensive class. And then somehow they created like a scholarship for that particular class. And the requirement for let's say it was a scholarship for undergrad students. And I was an undergrad, but I was also the only undergrad that the semester before took the slope stability class, because that was a graduate course. In other words, it was basically a figure just to get me to take the class. And I applied like the Friday before the class, and I got it. And I studied the class, and it was just a summer class. I had a lot of fun. I met Dr. Vallejo there. I mean, obviously, we became friends because I love everything he was saying, and he was extremely impressed with me because of the fact that I have all the geotech software that he was talking. The part that he never realized is that in Colombia, it was no copyright at that time. So you could go to any place and buy all the software that you want in a CD for like $1. So he never knew that part. So he always was wondering, like, wow, this kid loves his slope stability and has all the software. And he always thought that it was like with my own money. And I never even realized that was one of the reasons he was impressed. I thought everyone knew. I mean, that was naive on my side, that I didn't realize that, that copyright was a big deal, right? So I met him there, and life just works in mysterious ways. When he was in Colombia, he got notified that he got a grant from the National Science Foundation. But this was already, I believe, July. He had no chance to get a student to work on that grant, right? Because in this country, obviously, applications go way in advance. And by April, May, everyone knows where they are going to be during the fall, right? So one day when we were finishing one of these summer classes, he asked me to stay, after the class, and I did. And then with absolutely nothing else to say, he said, I'm very sure that you love geotech and you love slope stability. What about coming with me and doing a master's at Pitt? And I just remember thinking, like, yeah, that's awesome. I mean, that's the opportunity of a lifetime, right? But like, I was still finishing my undergrad. So I said, yeah, I mean, I'll finish, right, in 6 months. I still had 6 more months to go. I was doing like a dual program. So like during my undergrad, I was taking a lot of advanced classes. So once I finished my undergrad, I could stay just for like less than, I think a year, and then I will have my master's. So I say, let me talk to my professors, and and then he say, no, I need you like now. I need you like in 2 weeks in Pittsburgh, right? And then I thought like, man, that's impossible. It's like, how the hell? Keep in mind, I used to have long hair, 22 years old, didn't care much about many things in life. I was up for, actually, it's like the guy that you see on the left of that picture, right? With the long hair. So I thought, okay, well, let's give it a try. And I talked to my professors there, and they were super understanding, and they say, let's try to see if we can work out, because I have so many like advanced courses that I shouldn't have at that point. They were able to give me credit for like, I think I still have to take like couple easy classes or something like that that were not even in engineering, and they're like, we'll give you credit for that. And I still have one more class that I needed to get. So we agreed that I was going to do a project in Pittsburgh while I started my master's, and they will give me the credit there. I mean, long story short, and I guess the essence is that when I came to Pittsburgh, it was not like I have everything figured out, right? I mean, I did not have my degree yet from my undergrad. I still have one class that I needed to take. So Dr. Vallejo came and appeared in the picture and basically waived any kind of requirements. I mean, he saw the interest that I have, and I guess he saw some talent in me that I was not even aware that I had, and he bent all the rules. I mean, I just remember, when I started, you have to take a PIT. This is 20 plus years ago. When you arrive, you have to take the Michigan test, which is an English proficiency test. I was super nervous. I take it and I suck on it, man. I mean, it's like literally, I got recommended for 4 classes of English before I could start engineering. And then Dr. Vallejo was like, well, that cannot be right. This guy speaks. I mean, obviously, I got nervous when I took the test. I mean, imagine coming from another country and like the day after. He went and talked to Dr. Quimpo, which was at that time, the director of the chair of the civil engineering program, and explained. And then we went and talked to, at that time, was the dean of the School of Engineering. And then Dr. Vallejo say, I'm putting my name on this guy. I can guarantee he's going to have no issue. So we actually went, and they allowed me to register. I still have to take my 4 English classes, but they allowed me to take them at the same time that I took my engineering classes. So it was amazing, and the first few semesters were hard, but he completely put all his trust on me. And, even he presented in a way that I didn't even feel that I have the pressure, right? I mean, he was like, don't worry, you will be fine. And I was fine. I mean, and then for the next 5 years, I did my master in 1.5 years with him. Then after that, I was very happy with him, and he kept getting money from different grants. So we continue working, doing research. I stayed 5 years of it between master's and PhD, 1.5 on the master's, 3.5 on the PhD. We published 20 papers together, which still is amazing. I mean, there is more papers that many faculty actually had at that time. It was great time for me. It was great time for him. At that time, he was promoted to associate professor. He was associate professor. He got promoted to full professor. With all the research that we were doing, and it was great memories of my life, and I think it was also great memories of his life. As a person, he was also the most candid and inclusive person that you can imagine. When I was coming to Pittsburgh in this rush of 2 weeks, right, of while we kind of did the deal in Colombia, and then I ended up coming here. Obviously, I didn't have a place to stay or anything when I came, and he was in vacation with his wife, which appears Mary, and Johanna, which is his daughter that he's, Dr. Vallejo is kind of lifting in the air. And, they were going to Cancun. And just look the quality of person that he was, that he told me, I will leave you the keys of my place, right? With a grad student, and that grad student is going to go and pick you up at the airport. And then you can stay on my place and try to go to school, try to go register at P, do any kind of exam that you need, which was that Michigan exam that I failed. And get the thing together, and then I'll be back in a week, and I'll help you find a place. And I did that, and I stayed in his place for like a week, walking to the university, coming back. Then once he came back, his wife actually helped me to find a place, which was not easy. If you arrive to Pitt 2 weeks before the semester starts, and you try to find a place, it's almost impossible. But yeah, we did that, and then through the years, we remained very, very good friends. I mean, just looking at the images is kind of tough, but one that we have there is we won the American Society of Civil Engineer Geo Institute base paper on numerical modeling, which is a huge deal, and we won it in 2006. And I think it was one in Atlanta, in a conference in Atlanta. And I just remember all the joy that we had together, because this was kind of like at the end of my PhD, and that paper was really, is the effect of the pile shape in particle crushing. Nothing with landslide, but it's still foundations. And and I just remember the joy, because it was like, we did an amazing thing, right? In 5 years, we took this research, we papered this paper, we published all these papers, and we even got an award. So yeah, so that was very special, and I still have it. I think it's right here. If you look at it, it's like I have it right on my award shelf over there.
Nice.
And it has both our names and all that. So yeah, cool memories. On other aspects, he was the one that introduced me to pit football. I didn't know anything about, pit football or anything like that. There is no American football in Colombia, so we went to a lot of games together. Also on basketball. Those were the good years of basketball at Pitt, 20 years ago. So a lot of good memories. And as I said, I was very happy that I got when I was in Colombia, I don't know, a couple of months ago, more than a month ago, when I visited him, I was very lucky to see him twice before he was returning to the US. And the second time that I saw him, I think he knew it was the end, or the end was close. I was not aware. I mean, I thought that he was going to have more time. I think at that time, the doctors have already said that obviously it was a liver cancer and colon cancer. So you cannot survive that, right? I mean, and I'm sure we all have lost people due to those cancers, and we probably will lose more. But, I mean, at least we thought we were going to have a little more time. That's what I thought. I think in his mind, he knew he was probably not going to have. And the last thing that we talked just really showed the person that he was. And he told me, he was connected with me on Facebook, and I don't think on LinkedIn, but at least on Facebook. And he always look at my post, all the projects that I do and all that. And he always leave me a comment. And at the end, he said, I'm very happy for you. It was like a strange comment, because imagine that you are saying bye to someone and say, I'll see you in Pittsburgh, right? Safe flight or whatever. And then he say, I'm very proud of you, and I do enjoy a lot everything that you have accomplished. And he even commented, because I received the Lifetime Achievement Award last year from the American Society of Civil Engineers. And also last year I received the Civil Engineer of the Year award from the Pittsburgh section. And he kind of broached on that, and he's like, I think for him, he was saying that it was amazing to see in 20 years, what happened to my life. And obviously it's all thanks to him, right? So I think it was, at that time, I didn't realize it, to be honest. I think also you have a defense mechanism that you don't want to think about those things, right? You are never going to think this is the last time I'm seeing him. You just want to say I'll see you. I told him, I'll see you in Pittsburgh. I'll visit you as soon as you come, which I never had the chance. But I mean, I think it was, in some respect, it was a goodbye that it was, I don't know, it was emotional for me. Not at that time, right? At that time, I was very close and think, but after he passed away, and I kind of keep reminiscing about the moment, I completely understood. And I really saw what he was trying to say. And I mean, I'm very glad that he got to see all that. And I'm very glad that, he was happy with me. And the part that said that it represents so much is because I'm only one story, right? But don't think that Dr. Vallejo was just me. There is many, many people that can tell you exactly the same thing that I'm telling you right now. So he helped so many of us. I opened the door. I was the first one that came from Colombia after Dr. Vallejo taught that class. There were probably 10 of us after that. And it's the same story. I mean, is he going above and beyond for people and getting really good students? And, in my opinion, those were some of the best years of Pitt Geotech, because we were doing so much research. He was bringing so much money from different foundations and things, and it was great. And I always say that Dr. Vallejo was the definition of inclusion and diversity, even before those were things, right? I mean, he always welcomed everyone. As I said, he welcomed everyone on their house with absolutely no problem. And he always had that happiness and that, that humor in his life. I mean, he passed away, and I put all, all these posts on social media, and for me, it was overwhelming to see the number of people reaching out and saying, the memory they have from him. So, unfortunately, that's life, and we all have our days counted, but it's all about making them count, right? I mean, it's all about
Yeah.
making an impact. And in my book, Dr. Vallejo is pretty cool guy that have a deep impact on many of us. And as I said, he was the one that also got me into the slope stability profession. I mean, I liked it before I met him. Definitely took him to another level with him. Yeah, always only best memories. That's the only thing that I have about him. So yeah, so let's make this episode very, very cool just for him, right? I mean, it's our tribute. It's definitely my way to show what I have done in the last 20 years and what I learned from him. And hopefully we can motivate more people to get in the field the same way that he motivated me to be on the field.
Oh, absolutely. And you know what's kind of funny? He also had indirect effects, right? Because I never directly was in contact with Dr. Vallejo, but like he progressed the geotechnical like field in civil engineering so much that it touched myself and many generations of civil engineers at the University of Pittsburgh,
Yes.
Yeah, I mean, he was pretty much the godfather, right?
He
of
was, yeah, he
geotechnical
was.
engineering.
Yes, he was. And
For
and
sure.
and he's definitely, he definitely left some big shoes to fill for the next person that comes. But yes,
I would say so, for sure. But yeah, so this, I guess the second half of this segment is going to be on an introduction to landslides. So first of all, maybe we could start out by this question, and I'll pose it to you. What are landslides? Maybe you could go through the type of landslides that are
Yeah.
on the slide, for everyone to
Yes.
see.
So yeah, I mean, basically a landslide, it's a move of a mass, right? It's basically a mass that is typically on a slope or a hill, and then it activates and moves down. There are many ways that, I mean, I qualify them in two major categories, which is rock or soil, right? The reason is because they behave a little different. But let's start, for example, with the plot. So you can have rotational slides, which is like a circular failure. That's probably the most common one.
Yeah.
You can also have translational, that is more like, instead of being a circular, it's more like a failure plane, like a straight line, like an infinite slope. So those are probably the two big ones: rotational slide, translational slide. You can have block slide. Now we kind of get into different names, and to be honest, it's not that important to remember every single name, but just to kind of give an idea. Block slide tends to be more let's say like a rock slide, that you have blocks that are coming down. Not that different from a rock fall, right? I mean, it just kind of depends on the slope. The toppling, that's a little different, because everything we have talked is rotational like that, or sliding going like that. It's basically shear at the base. Topple or toppling is different, because it's more like you have a column and then something push it and then it just goes down. So it's literally a rotational failure, but instead of going like this, is the top going down. So it's kind of like summatory of moments, if you want to see it on physics, right? So it's like I have this, right? And then I just push it at the top and then it just goes down. While the other ones are more like the base is the one that is rotating. The reef flows are very, very important. Dr. Vallejo worked a lot of his life on the reef flows. It's basically saturated soils, clays, and different deposits that just get so saturated with water that they actually become almost like a fluid. Some could be so saturated on liquid, but they also can even flow on air if they start kind of fluid, like mobilizing very, very fast. Avalanches kind of go similar to the reef flows. I mean, I think we all know avalanches from snow and things like that, so it's very similar. Mud flow is like similar things. And then creep is probably one interesting one, which is not these basic movements that we are describing, like translation or rotational, but it's more like the entire profile is kind of creeping or repting very, very slow. So the definition of creep is like a plastic flow. So those happen over a really long period of time. So it's not like you see them. The other ones that we have been described is your typical slide that you see next to the side of the road, or in Pittsburgh, capital of landslides in the world, as I say, that's what I live here, right? You can see these all over the place, for different reasons. I mean, the main causes, I guess, to begin with, the main causes are water, right? And I do this as a joke. It's a joke. It may not be a good joke, but I say that water is the enemy when it comes to landslides. And as humans, we are really doing a great job getting rid of water, to stabilize landslides. So it's an irony, right? It's a joke. Some people don't get it, but unfortunately, we are doing a really good job on messing up the whole system. And
can I interject real quick? So just to be a little more descriptive rather than visual, since some people will be listening to this, if you look at creep, right, you'll probably see this. Like if you're ever walking in a park and you just look at the side of the hill and you see that like the base of the tree is like kind of like bent towards where the tree starts to become vertical again. It kind of, I don't know, looks like a really like a curved hilt or something like that at the bottom. That's usually the result of creep, right? You know, it's people wonder like, why is the trees, you know, bent like that? It's because the hillside's literally moving. It's creep.
Yes, exactly, and that's a great point, because you see it on the trees. Since they grow so slowly, right? They kind of rotate, and that's the evidence, and that's the way that we find them on the field. You know, just looking at the trees and see their shapes.
Right. And okay, so we've covered the types of landslides, and I understand it, like to the layperson, it doesn't really matter, but it's really cool just to see how many different, you know, failure types there are in landslides. It's really cool. You just think of a landslide, you just, you know, picture what you usually see at the side of the road. There's a lot of different things going on. But,
yes, and it's important to understand them, because we'll go in a second in that, because the way that you fix them also changes, right?
Correct. So how do landslides occur, right? There's two different causations. There's the natural and then there's the human influence. So would you like to take it from there?
I mean, there are multiple reasons, but to summarize them, the human one could come on two forms. One, I mean, everything comes because we mess up with nature, right? So one easy way is that you remove what is called the toe. So imagine that you have a slope that is stable by itself. Sometimes because of human activity, we come and kind of take that toe out. We do excavations at the bottom. We do something without thinking that destabilizes this. And once you take the toe, the whole thing comes down. So that's one way that we create them as human activity. Another one is to put load, right? I mean, if you have a slope that is stable by itself and you load it up at the top, now you're creating more force coming down. So those are two typical ways that, you know, that we do it. And it's interesting because when we go back to the fixes, we're going to go back to the causes. Now, with nature, there is also multiple ways, but just to make the main ones, rain seems to be the most important one.
Rain.
There are two things that the rain affect. Without getting into very complicated terms, there is something that we call the effective stress in the soil, which is basically how much weight you have on top, how much weight of soil you have on top. That gives you the vertical component, end up resulting in a normal force that give you a shear component, right? Everything that works on these circular failures or infinite slopes, everywhere that we have a failure plane, you know, either a plane completely or a circular surface, the soil is only resisting thanks to shear, thanks to friction at that base. And that friction is a function of the vertical load that you have. Now, that vertical load changes with water. And this is just the principle of buoyancy, right? Because what happens is when you saturate a soil, why does a soil behave differently when it's saturated? The friction angle or the resistance will be the same. It's just when you have water, you have buoyancy, so you have less normal stress, right? Because the water is the one that is picking up the weight. The pore pressure is the one that is lifting. So if you see the grains of soil, they have less normal stress. And as a result of that, the friction decreases. So it's extremely interesting. And the basis on this is exactly just that, is the effective stress. The more water you put, the more you raise the groundwater table, the lower the frictional resistance is on the soil. So when you have rain events, these, like today in Pittsburgh, is the perfect example. Like, you know, April and May, it's the time that you have a lot of rain, it infiltrates on the ground, raises that ground surface, that water level, sorry, and then that activates the slide. Now, that's one way. Another one, so as I said, like a sand, a material that is already a sediment, the frictional resistance, the friction angle of the material, let's say the shear between grains don't change. The friction angle remains the same, but the effective stress changes because of the water goes up and down. So, but you know, the friction remains the same for the material, the friction angle. However, that's not the same case when you have, for example, rock slides, or you have materials that weather down. So let's take, for example, a shale, extremely common here, or a claystone. Those materials tend to be rocks that have some good strength. But the moment that you put them on water, and when you let's say you saturate them and then you dry them and you do these cycles, you completely weather the material, right? So once you weather the material, your friction changes. And I have plenty of projects that is like, it was a nice rock slope with a little bit of an angle. You have a shale layer that was fine until it was not, until a lot of water infiltrated, completely completely weather that layer, and it passed from rock into a clay. And then it's just like if you are on a soap, you just
Yep.
go like that. So that's another reason, like, physical or chemical weathering, if you have another agent. And then one of the ones that I see that a lot of the time is, it's also related to water, but instead of being rain, let's say that you have a slope that is stable and then a stream at the bottom. If the stream end up kind of eroding the toe, it's similar to what I was describing as human activity. You take the support of the slide and things fail. So the mechanisms are kind of easy to understand and common sense. Sometimes it's human activity, sometimes it's nature itself, but it's very basic. I mean, it's the part of what I love of slope stability is that I can guarantee you, if you took a physics class in high school, you can understand slope stability, because it's a statics of blocks and masses coming down. Friction is your friend, and that's pretty much, and then the normal force. So that in a nutshell is kind of what causes landslides and what we see it. So that's the reason that you see it when there is a lot of rain. You also see them when there is a lot of like streams that change level and go up. And you also see it when engineers do things without thinking, right? And cause, because unfortunately there is a lot of landslides that are caused by human activity without major, proper thinking behind.
Yeah, and one other thing that kind of comes to my mind is you talked about weather or rain, and something that is plaguing us is that as time kind of moves on with the direction that we're heading. I hate to bring in climate change. I feel like we talk about it with every scientific subject that we talk about, but I mean it makes sense, right? So usually your weather intensive. So where you're having weather, right? Say take Pennsylvania. Pennsylvania is a pretty wet state. So the wet states will get wetter and the arid states will get more arid, like where I'm at in Phoenix. So what I'm seeing here is that there'll be an uptick in also natural caused landslides over time if the climate continues to become
that's a great point.
Creates more drastic weathering.
Yeah, that's a great point, because I mean, I can tell you, I've been doing this for 20 years now in Pittsburgh, and if I take the number of landslides in Pittsburgh, it increases, right? And that's what I'm saying. For me now, the months of, let's say, March, April, May, it's like 90% of the jobs that generate for the year, because that's when things start failing, and it has getting worse and worse and worse. The more the global warming keeps keeping, and we keep messing up with things, and the weather kind of pays the price, the more we get these excess precipitations, right? And yeah, for landslides, it's good for a business, right? But not good for everyone. So
not good whenever you have to shut down a road for a while.
Exactly. Yeah, I mean, and District 11, for example, on PennDOT, it's amazing. It's like the number of jobs that now they get, it's insane, because it's like how you maintain all these roads, right? I mean, the major highways, maybe it's okay, but it's like all these small roads on the hillsides, they do an amazing job trying to get an inventory and trying to keep an eye on everything. And I work a lot with them, and I mean, really, they do an amazing job trying to. But it's just sometimes it's like a fight that like, how can you fight nature like that?
It's pretty tough.
Just do your best. Yeah.
Absolutely. Best. So, okay, so we've kind of mentioned mostly Pennsylvania, right? But obviously, this isn't just occurring in Pennsylvania. So where else are we seeing a lot of landslides occurring? And maybe we could just give a typical example based upon how we've already talked about the causes.
Yeah, no, I mean, in general, like any area that has a lot of precipitation will always have landslides. Let's say rainforest countries, let's say Colombia has a lot. I mean, that's probably the reason also I fall in love with landslides, because of that. South America has a lot. I've seen a lot of stuff, and I'm participating in a lot of conferences in Peru, Colombia, Bolivia, and Brazil. And every time that I attend one of those conferences, you see so many case studies of massive landslides and things like that. But even if, and obviously that also goes like into the same latitudes all around the world, right? But even if you don't go into that, I mean, landslides are everywhere. Like in Alaska, I went to a conference of landslides in Alaska 15 years ago, or probably more. And then you get also, because the rivers there move so much, and the weather also it's so crucial that I mean, at this point, to be honest, you have a landslide everywhere that you have a mountain. It's bound to happen at some point.
Of course.
And then you have things like, Peru 2018. I mean, like you have massive landslides like that, obviously that was like a pressure bomb cooking for many years before it happened, right? And some of these landslides are like that. I mean, some of these landslides take a long time for that water table to go up, or for that toe to be eroded, or for whatever is happening. Now, the other part that I haven't really mentioned, because we were focusing more on Pittsburgh and Pennsylvania, is the seismic aspect. But obviously, landslides are triggered by landslide, because imagine that something is kind of on a limit equilibrium, and then you get an earthquake that basically just put inertial forces and just push it. It just gives it the last push that it needed. So you see a lot, for example, in California, you see a lot of landslides next to roads and things like that. And then on the Andes, Peru, Colombia, all that. I mean, every time you have some kind of seismic event, you have, I have a very good friend in Colombia that he's the general manager for a concessionaire, which is basically a company that maintains a road, right, for like years, and they collect the tolls and live from that. And he sent me the craziest pictures of all the lands that they have to deal with, and yeah, it's crazy. Every time you have rain, every time you have some seismic activity, it's a fight against nature that it's hard to win sometimes.
Right. And we've talked about mountains, and we've talked about, rain, or, really weather intensive areas. But another thing is also these dry, arid climates like Arizona, where you'll get, you'll be dry most of the year, but then you'll have a really nasty rainstorm, and it creates like flash mud flow. Because one of the failure types that we were talking about was right here, the mud flow slides. So you could definitely still see landslides in mud flow in very arid places.
Yeah, no, you're right. I mean, just because it's typically dry doesn't mean that it's safe, right? Because these flash floods mobilize everything, and you have these avalanches and debris, and sometimes it's even worse, because at least in Pittsburgh, people are prepared, and they have, there is many companies that can fix these things, but sometimes in areas that you are not expecting them, when they happen, they are worse.
Oh, absolutely. Yeah. So and we even touched about the time relation compared to a lot of these events. Like you said, that it could be a ticking time bomb, but also it could happen within probably even just a few months or even a few years, right? So we're talking about a really broad spectrum.
Yes, and there are some slides that keep moving for years. Like I work in one here with the company I work for, which was the New Baltimore landslide. It was reported to be moving for 60 years. 60 years, and the turnpike, they just keep doing maintenance and kind of cleaning the toll. Like they basically got, we monitor it for about, I think we monitor it for about 15 years, out of those 60s with different technologies. And we concluded it was moving a foot a year, and it was very slow movement, right? And everything moves, and then you just keep cleaning it until finally, it was time to fix it. But yeah, so some landslides, especially the debris flows, the avalanches, those are very fast. Some others take 60 years, right? But they keep moving in a fast pace, an inch a month. And then you also have the creep that could take decades to just move an inch. So yeah, they
definitely.
There's so many types. That's what they make them exciting to study.
Absolutely, yeah. Even with just my brief exposure I took an engineering geology course and then soil mechanics.
Yeah, the basics.
Yeah, it was really fun. I thought it was really cool. I mean, going into it, I didn't think there was that many different failure modes. I thought that was really neat.
Yeah, it is more complex than initially what someone can think.
Yeah, and I thought it was honestly my downfall in terms of engineering geology was just trying to remember all the rock and mineral names.
Yeah,
that was my downfall. But I thought this was really interesting.
Yes,
this was a really interesting concept.
Yes,
but yeah, so we're going to take a quick commercial break, but then whenever we come back, Sebastian's going to be talking about the effects of landslides. So stick around.
I have some exciting news. Everything Steam and Elite Graphics have teamed up to create Ecolite Apparel. Ecolite Apparel has a direct focus on the environment with a sustainable approach to fashion. We came up with a way to combine fashion, sustainability, and education. Firstly, our apparel is sustainable because it takes advantage of organic materials with a blend of recycled materials to combat the waste of the fashion industry. So speaking of fashion, each Ecolite product has a significant environmental symbol, such as reduce, reuse, recycle, planting trees, saving the bees, commercial fishing, and much more. Everything STEAM and Elite Graphics are going above and beyond to provide you with more information about sustainability and environmentalism through the use of Ecolite. Each piece of our apparel will contain a scanned QR code, and when you scan this QR code, it takes you to Everything STEAM's research blog that is specifically about the symbol on the clothing that you purchased. So let's say you purchased our t-shirt with the symbol for planting trees. Your t-shirt will have a scanned QR code that will take you directly to our Plant a Tree research blog, where you can learn about the many benefits of trees, global deforestation, reforestation acts, and what you can do to make a difference. Last but certainly not least, with each purchase of Ecolite, we pledge to donate $2 to nonprofit organizations that are on the front lines of fighting for our ecosystem. We plan to target reforestation nonprofits and other organizations that fight over fishing, plastic pollution, air quality, and much more. To purchase Ecolite apparel, head to the Elite Graphics website, elitegraphics.org, or make your way to our sponsors page on our website, everythingsteam.org. So, do yourself a favor and get yourself some Ecolite apparel, the clothing line that combines fashion, sustainability, and learning. Ecolite, clothing done right.
Okay, well, welcome back to segment 2. We're going to be talking about the effects that landslides have on reality. So, Sebastian, we did outline a few different things that we really wanted to touch home on. And the first one was site remediation. So do you have any comments on that?
Yeah, I mean, part of the effects of landslides, right, is that you are going to end up with a problem, right? So like the pictures that you are seeing there, like the effect of this is like, what do you do? The picture on the left is a project that I got on in a neighborhood here in Pittsburgh. And what you see, I'm kind of standing on the road. The rest of the road is gone. The grass that you see behind, like if you follow the road, well, that grass was like where the trees are, right? It's just that it moved down. And there were 3 houses. There were 3 houses there because the road was going like that and then turned. All that got destroyed and went down. The houses were down. So obviously, the first impact of landslide is, unfortunately, is the loss of, let's say, the loss of life, which is the worst that could happen, right?
Yes.
And that happened a lot. I mean, I will always remember a tragedy in Colombia, in Armero, I think it was 1986 or something like that when I was a kid. It was a big landslide and avalanche and basically ended up sweeping a whole town. Those are the worst because, unfortunately, they don't give you much of a warning, right? There are other landslides that you typically start seeing the signs. You start seeing the cracks on top for the circular failures that we talked before, or the translation failure. You start seeing cracks, which is the scarp. It's always called the scarp, the back of the landslide. So, loss of life and then loss of property, right? In this case, like those houses. The picture on the right side is just a jewel because it was a job that I was called in Oakland, here in Pittsburgh, and you have Cathedral of Learning right behind, right? So for me, it's like, if you love landslides, you came to Pitt to study landslides, and then you get a job that is a landslide close. I mean, I cannot tell you how long it took that picture to get the angle so Cathedral was in full swing. So, but basically, I'm standing on top. So, yeah, so that will be the first thing, is the loss of infrastructure. So typically, I mean, if a landslide happened in the middle of a jungle and nobody see it, is that really a landslide? I mean, it's, what we said about if a tree falls in the forest and nobody's around, did it fall really? So in this case, like, yeah, the effects are very minimal, let's say, or could also be really bad, as some projects that I did in Ohio that were landslides in the middle of nowhere, but the problem is that they were blocking streams. So then it was a DEP issue, right? Because then these streams were getting blocked and then they were getting saturated. And then after that, they were having avalanches. So that's a different thing. So typically loss of property, loss of infrastructure, closing roads, right? So that becomes either private property or public infrastructure and things
even
like that.
Utilities, right? Like you would see utilities.
Oh yeah, utilities are the first ones to go. So and I think in that picture you can also see a pipe coming out. So it is always that's really when I come into the picture, because that's the reason that I'm called, right? Something happened, a landslide happened, or it's starting to happen, and there is some concern from an owner point of view. Something is being in danger that needs to be protected. So that's really the beginning of things.
Right. And wow. Yeah. So there's even, so we already talked about a little bit about the infrastructure. So skipping ahead, there's also the environmental changes. You did touch on it where you said that it could create, future avalanches. So it's doing like a domino effect almost. But that also creates something else that's, kind of vital to, an ecosystem is sedimentation, right? Because whenever you get excess sedimentation in waterways, that typically creates an effect within the entire the chain of living beings, right? From the top down. It blocks out sun, kills different bacteria and different organisms, and then it just creates a whole cascading effect. So I mean, what other environmental changes comes to your mind whenever you think about landslides?
Yeah, no, I mean, I think it's pretty much what we said. One is that you retain the water and could come into like an avalanche or something. The quality of the water decreases significantly, right? I mean, even because now you're putting saturated mud and saturated, soils that were not even supposed to be there. The habitat changes a lot. One of the scariest part, I mean, I love doing recons and going to things like that. I always take my son with me to these things, but I'm always very careful because you typically see a lot of snakes when, once you have, yes, exactly. So here he is. So you also see a lot of snakes and a different habitat that obviously things just move for them, right? So they are kind of trying to look for something. So I remember once in Ohio walking with one of our young engineers doing a recon, and then we saw a rattlesnake. And man, it was like a huge rattlesnake, and I didn't even see it. I was walking, and then the guy was like, it was like exactly like Jurassic Park. He was like, "Do not move a muscle," And I was like we're in the middle of Ohio, man. It's like we're like hours driving. There is, what could be dangerous? And he just said, like, look on your right, and just try to slowly walk away. But yeah, so it's like I love taking my son, but I never take him on the first recon. I always make sure that it's like projects of the one on the left, that you have an easy way into it, right? I mean, that's another one that is impressive. I mean, just look the mass that went down, and you can see those buildings on top. Yeah, and this is always a duality, because I mean, obviously you love the challenge from the point of view of the science and the engineering, but it's hard not to feel for the people that are being affected, right? I mean, imagine that you own a condo on that building. I mean, your life just and that part really is something that interests me. Not only the engineering aspect, but the personal aspect, and that's something that I also try to help. The company that I work for, we don't take into like homeowner projects. It's just because of different liability policies and things like that. We always want to deal with owners that are more, let's say like companies or but it's not like a homeowner, because it's very hard to I don't know, to deal with them. And there is different reasons, and most companies also have the same issue. But every time that I get a call and I cannot help as a person fixing it from the point of view of my company, I try to go there and kind of guide them and give them a path and say, okay, you need to contact this person. Let's try to do some borings. And I try to advise them, because I always feel that it's a tragedy. Imagine that and I mean, as I said, I have been doing this for years now of helping different people, but every time that you approach them, is the most important thing that you have typically in your life is your house, right? I mean, it's where you invested all your money that you have been working for years. And it's where your family grows, and it represents everything in your life. And then you have a landslide, and like that picture, right? And completely screw it. So yeah, so I'm always very sympathetic with the situation, and I try to help them, and it's a pretty cool thing. And I think the word is spread very fast. So I get a lot of contact from people that I don't know, and it's like a friend of a friend of a friend told me to contact you. And yeah,
Nice.
Even my wife understands when on a Saturday I get a text message like, sorry, I need to go and help these people, because like I imagine that happening to me. So I mean, needless to say, I will never buy a property next to a hill, but that's a different part, right? But yeah, so but it's so that's another aspect that it sometimes is not really commented, which is the impact on the lives of people. Not only the value of the property, but it's like how disruptive it can be.
Absolutely, yeah. Like you said, it could be a house, it could be a business, you could possibly even lose a life.
The ones on roads, like the other picture that is, I'm standing there with my dad, which obviously he was one of my first mentors on landslides. Roads are different, because I think when you, I mean, obviously it's public infrastructure, but
yeah,
there, obviously you don't want any of this happening when people are on the road. But closing a road is not the end of the world, and it's something that can be fixed. And I guess we all pay it on taxes, right? But it's not as being just one individual having to deal with the problem.
Right, exactly. And it's just also them trying to get to their, their livelihoods or get somewhere that, that they need to go. So there's a lot of
Yes.
societal impacts to that. And I don't think we didn't really talk about that whenever we first met about, the different effects of landslides. I'm glad that we got to cover that a little bit.
Yeah.
And the last one that you and I had laid out here was the economic impact, because from what I was told
Huge.
is that it's like if you have a landslide on your property, you might as well just go find a new property and build
Well,
your
the
house
first thing
again.
you called me, I'll kind of advise you. But yeah, typically, yeah, because, and I have helped people also giving them like a cost estimate and say, like, if I was taking this project, this is what I think it will cost you, not only on my fee, but on the contractor fee.
Right.
And many times the fix is it's more expensive than the land itself. There is a whole field there also with insurance. Some insurance are very good, some insurance are not. It goes into what is, yes, so legal reasons I cannot tell you, but the definition of an act of God, right? I mean, because this goes into an act of God, and if it's something that truly was an act of God that nobody knew that it could happen, but most of the time they are not. There is a lot of issues with, let's say, public utilities that because they are old and they start leaking, they saturate the soil, and then it makes a failure on a property, and then the owner is like, I know it, my property failed, but it's because your utility was leaking, so it's your fault and you have to pay. And then the insurance is going to go and say, well, it's not an act of God, so I'm washing my hands out of it. It's a very complex situation, but the only thing that I can say is the city of Pittsburgh is amazing when it comes down to responding to, to landslides. I have been involved in many that I can almost tell you that it's not even the blame of the city of Pittsburgh, but they help the citizens of Pittsburgh so much that they will go and fix it. And the insurance is also very responsive. Most insurance are very responsive. There is still a few that are not. So yeah, so I mean, it's a positive scenario in the same, but it's harsh. And many people that I have advised, they have to go through a process that may take a couple of years just to finally get. But I can tell you that there is nothing more satisfying in life than seeing one of these homeowners when everything is fixed. And like sometimes they invite me just to see the final configuration of things and just seeing their faces going back to normal and a landslide being repaired. Most times that you replace a landslide, you end up having with, and we'll talk about it in a second, but you end up having anchors, nails, and and piles and all kind of stuff that is geotech construction. And I always kind of kid around and say, well, I would love to have like a micropile on my backyard because I think they look cool, and anchors and all that. So I don't think they see it that way, but at least their property is back to normal. So that's always
right. Cool. Right. So I'm just kind of curious, based upon, your vast career, what is probably the lowest cost that you've ever seen, like on a landslide, like for like residentially, and then also what's the biggest cost you've ever seen? And that could be, public and private. So I'm just kind of curious. I'd love to hear some numbers.
I think public, the biggest one that I have seen is probably I would say $60 million was one that we did, which is a massive landslide.
What was that?
I cannot tell you because it ended up going into a litigation, and you cannot reveal the cost, of the thing. But I know how it was because I was working with the contractor. Wow. But I can tell you another one. Let's say the new Baltimore landslide on the Turnpike. I don't remember exactly the cost, but that one was cheaper than the 60 million. That probably ended up going for like 35 million. It was a lot of material that has to be removed. But obviously those are big ones, right? You also have, I would say residential, it depends. If you are talking a small residential, sometimes can get fixed for like 50 grand if it's a small. The most common ones that I have seen goes for between 150, 200,000. So, I mean, yeah, so it's tricky. Like who has $200,000 on pocket change to cover a landslide, right?
Right. And it also depends on, how you're fixing it. Like what's your plan of attack, and that also depends upon your situation. Like you said, there's different ways to fix things depending upon what type of landslide that you're having, whether it's a mudslide or a rock fall or a rock slide or
and that's my favorite part, and I'm sure we're gonna start talking about that in a few minutes. But the fixing, right? That's what I'm here for, the fixing of the landslide.
Awesome.
That's where the good things happen.
Well, I'm glad we set it up, because whenever we come back from this commercial break, we're going to be talking all about remediation.
Fixing. Yes, that's what we like to do. Fix the landslides. That's how we make our money. That's how we make people happy.
That's right. All right, stick around.
Have you ever been standing in the shower, looking at the ingredients on your shampoo bottle, and noticed that water is always the first ingredient? Well, I have. After a little research, I discovered that shampoo is over 80% water, which is kind of like dumping bottled water on your head while you're standing in a shower. And that's why I'm excited that I found Seabar, a disposable plastic-free hair care line that cleans up ocean trash with every purchase. Not only does Seabar pick up 1 pound of ocean trash for every item ordered, but their salon quality shampoo and conditioner concentrates come from refillable applicators, kind of like deodorant tubes. Just twist them up, rub it on over your hair a couple times, and then just lather it up like you normally would. My favorite part is how long they last. I've personally been using the same Seabar for 3 months now, and I've barely used any. So not only does it help save the environment, it's also effective, efficient, and most importantly, it saves me money. If you would like to try a better way to wash your hair, head on over to seabar.com and use our special code STEAM for 15% off your first order. Seabar, shampoo done right for you and the planet.
Okay, we're back to the last segment. Wow, segment 3, it's went fast. It feels like it's went fast, hasn't it?
Yeah, no, I know. That's what happened when you're having fun, right? Time flies.
Yeah, definitely. So this last segment, we're going to be talking, like as we set up before, we're going to be talking about remediation and some prevention. But first of all, I really want to, put a little emphasis on the slides that we put together. I know, bear with us, audio people. We are going to try to be as descriptive as possible, but I would like for Sebastian to go through some of these slides and just explain it a little bit, because they're really cool images. And also, of course, we got Sebastian in each one.
And every single one, yeah. And I have to give the little disclaimer that obviously I love these projects and identify with them. And I always like to take the selfies and put it on LinkedIn and Facebook. And if someone is seeing this and or listening and you are not connected, make sure that we connect on LinkedIn, because I definitely love doing that and sharing things. So yeah, so just bear with me if you see me on all the pictures. It's just my thing, right? I just appear on all of them.
Oh, so actually, if you want to connect with Sebastian, you can go to our website and go right to like this episode's page, and then you can click on connect with Sebastian. It's right with his bio, and it'll take you right to his LinkedIn page. So it's just I try to do that with all the guest stars.
Awesome,
that way,
awesome.
yeah, got to return favor somehow, right?
Yes. No, appreciate it. So yeah, so let's get started. So the first one is deep-seated failures. So deep-seated failures, as the name says, is deep, right? So what we see on the pictures, for if somebody's not watching the YouTube version, is you have a mass that start moving, you have the scarp, you have a very thick, it could be the circular rotational, or it could be the translational that we described before. Generally, those are triggered by water, by the groundwater going up, decreasing the effective stresses, decreasing the friction, and then these going down. The deep-seated are the ones that are probably sometimes more difficult to manage, because you can see the size of those scarps on the picture, right? I mean, 10, 15, 20 feet. So obviously when they mobilize, the damage is done. So we will go back into that when we talk the fixes. Yeah, this one also, it's also a very deep-seated failure. You can see the circular failure. That's the king. Circular is the king on deep-seated failures. The same thing that moved down, it finally reached a state of equilibrium once it started traveling and kind of like stop the movement. A typical sign that you see also is that not only is a circular failure like going down, but typically the scarp is also circular on a plan view. So like the picture that I'm standing with my dad, you can see that circular around us, or the picture with my son, you can also see that circle. So yeah, so deep-seated, deep-seated failures, which could be deep pocket fixes if you want to also see it that way. So let's see the next one. These are more like, miniature versions of the deep-seated. They probably are more like, we call them shallow. The mechanism could be similar. Most of the time, the shallow ones tend to be planar rather than circular. But in some cases, you can also see a little bit of the circle. Like this one that I'm standing there on the scarp, and Vishal, one of our engineers, is standing on the block, which is sometimes is not very recommended to do that, but I guess for the selfie. That really, you can see the block that is coming down is not as thick as the other ones. This to me is a shallow failure, but you see a lot of resemblance to the deep-seated. So you can call it like a miniature deep-seated that could be shallow. Shallow tends to be like the flat, translational.
Right.
So, all right, let's keep going. All right,
Ooh.
then we're moving now into rock slides. Rock slides tend to be, when you have a pure rock slide, they tend to be more on the translational aspect, not the circular. The circular is on rock slides when the material is so broken that it behaves more like a soil. The picture on the left is one of my favorite pictures that I have on a rock slide. It's basically a block that is moving on top of a claystone layer. The claystone layer ends up weathering down to literally clay, and then this block start mobilizing, and I'm standing on the, like on the back. So this, this kind of failure is what we call the infinite slope. We call it. It's just because this is your physics class from high school or college, which is a block just coming down, right? And I love it because you can solve this problem in a napkin. And I can tell you even the answer. The factor of safety of this is the tangent of the friction angle of the interface divided by the tangent of the slope. So I can calculate almost in my head the factor of safety for a slide like that. The one that is on the right side is the same. It's just that it's another rock slide, but it's significantly steeper. Like let's say the deep of the rock is it's significantly steeper, but it's the same thing. You can see that block that is next to where I'm standing. That block is ready to come down. So keep these ones in mind because we're gonna go back later on the fixes. These ones, they are deep, but they are not as deep as the first one for the soil, right? So the fixes sometimes are a little easier. At the same time, it's rock that tends to be a little heavier than soil. But so
that was so funny. I was literally just about to say, just remember, like if you ever studied physics and you see the common the common question of two blocks sitting on like on a plane, but the plane is tilted, right? The real thing is just like, okay, what is the angle? What is the friction? And then, if gravity is winning, then you get a rock.
Yeah, I mean, it's literally the normal force is W cosine of the angle, and then you multiply by tangent of the friction, right? And that's your resistance. And your driving is that W times the sine of the angle. And I know I may be sounding like a crazy guy, but anyone with a piece of paper in front would see it. And I love it because that's what I'm all about, which is simple physics equations that you can resolve actual problems. And that's what I say. That's the reason I fell in love in landslides. Dr. Vallejo was always all about that. It has to be simple. It has to be something that your mind can comprehend. And then that's the beauty of simplicity and the elegance of simplicity. And it's awesome to fix real problems with just basic concepts. So all up for physics, man. My favorite subject ever. So so this one is one field trip that we did with the entire company, and where this is actually a pretty deep-seated failure.
It is.
And it's kind of a mix between soil and rock because it's a rock strata with a very soft layer underneath that is being mobilized. We're standing on the back of the scarp, and you can see, I don't even remember how the hell we took that picture because the guy that is taking the picture, well, I guess it sucks because he or she didn't appear on the picture, but you can see the size of that scarp, right? And you can see the highway like on the upper left corner. So so that one is a rock slide, but you can see these. Obviously, the fix of something like that is a little more complicated because of the volume, right? I mean, if you see the highway below and this is the scarp, just imagine the remaining things.
Yeah, that's a lot deeper than I thought it was. Yeah, I originally putting up these pictures, I didn't see how deep that went. Wow. Okay.
Yeah, no, that one is super deep.
Oh,
yes. So these are some in Ohio, which are also, let's say some kind of like mass movement. This in particular was mobilized by water. It's just that it saturated those soils, and then it was like almost to the point that it was like a mud flow. I mean, you can see me standing with my mud up to kind of like, well, not my knees, but probably a little below. I'll tell you, that picture was great, but get it out of that mass, walking where to the engineer that took the picture was impossible. And the part that I like is because on the left, you can see it once was remediated. So in this case was very easy, because I think we're getting into, I think this is the point we get into the fixes, right?
I was going to announce that, but I didn't want to cut you off. Yeah, this is now.
No, because I see. Yeah, so this is the easy one to begin. So let's start in order. I got this question on a conference for Peru, I believe, like 2 weeks ago, and we were talking about landslide, and they said, in your mind, how is the process of fixing a landslide, right? So like, forget about the technical part, just what is the step-by-step procedure? So the easiest way to fix a landslide And it's not like I'm telling you my secret, because this is like really common sense. So if you have a landslide that is a massive something like this, the first question is, can I remove the mass? If I can literally just remove the mass that failed and put it somewhere else, boom, the problem is solved. You only have one concern. If I remove the mass, is what is behind gonna be destabilized, right? So what I'm saying is, if the landslide, because keep in mind the other pictures, when you have a slide, the slide typically end up going to the toe and stabilize what is behind. So even though it already failed, if I take this out, is it more stuff gonna come down? This project was paradise because the rock was extremely shallow. This is very low in Ohio, almost in Kentucky. And so the rock was very shallow. So what we find out very quickly is that we can take all that stuff out. Nothing else is gonna come down, because basically once I take the material that moved out, everything is fine. So that's what we did. Easiest fix of a landslide. You take the material out, right? And then you vegetate it and you are out. So that is the first one, right? Can I take the material out? Is there, and if nothing behind is gonna be destabilized.
So did you guys, whenever you went out there, did you take any core samples, or did you just literally take that piece of equipment, take that hoe out there and start digging, and then you're like, oh, it's rock?
No, so typically we do borings. We go and do borings. This one was fast and furious. And then with equipment, exactly as you said, I mean, we were planning to take borings, but then as we were kind of starting to investigate, we realized like the rock is really shallow. You could see it with the excavator. So that particular one, that's, I say, it's the ideal job. We didn't even do borings because, it's like we just kind of start cleaning and it's like, oh, rock is right here. Let's just leave it like this. And then the part that I never understand when I see this is the same site. And when I see this comparison, I don't know how the hell that tree in the middle is standing when we fix it, but it's not standing when I'm on the picture. It's like, I don't even remember, did we fix it? Did we put it up again? Or it's just magic, that just happened like that? Because it should be the other way. It should be kind of like, or gone. So every time that I do this comparison, I'm like, what the hell? I mean, this was like, I don't know, 7 years ago. So I'm always like, what the hell happened to that tree? But
that's hilarious.
The magic of landslides. So yeah, so let's keep going. That's the easiest one. This is the next step, which is another project, also in the state of Ohio, which we could clean the material, but the problem was that it was not really an easy, well, initially we didn't really have an area of putting things, but then we realized that we could locate all the material that failed. It was very shallow rock. We could put it at the top. And that was the beauty of it, because we end up doing like a very nice field at the bottom of the hill. And we basically put all the material, we just compacted. And then we put drains. So typically when you do these things that you are just removing a mass, you make sure that you put enough filters and ditches so the water, gets, and you can see the ditch with the rock, right? So basically you take all the filter water and you make sure that you have a path so that water can come out. And then vegetation. Vegetation is the key.
So did you do any tests to figure out where the water table was in here to establish drains?
No, not on this one. Again, this was for oil and gas, and they were just fast and furious. So we were just literally following where we saw the water coming from. So as you excavate, you see like the springs coming out, and then every time that we saw one, we put a drainage interceptor and then try to connect them. Yeah, this is an adventure that is. We did all this work in Ohio, 2015, so 7 years ago, and they didn't have time for borings or any investigation. They were like, we want you here and just direct the equipment, and so it was exciting. 7 days a week we were working there. So I was rotating. We have 3 inspectors on the job, and I was trying to visit at least 3 times a week. So
that makes sense. I mean, sometimes you don't, like, I ask these questions, but I understand that sometimes you don't need the extra investigation. You can just walk out there and be like, oh, there is rock here, or oh,
yeah, but
that's the water table.
Yes, but this is like 1% of my projects. Typically we do a proper subsurface investigation. We detect the water table with things. It's just sometimes you get lucky, like in that project. But
of course.
All right, so then we move into another way to stabilize them, which is now you realize that you cannot just simply take all the material out. You can take some of the material out, but you need to remain some. So in this case, this is a project in Altoona that it has a failure, and we removed the mass that was below, but we literally could not take the rest of the mountain out. So in this case, we were using deep foundation elements, trying to stabilize it, which is micropile and caisson. And the only thing you're trying to do is this. If the material is coming up and is pushing, I'm trying to do some kind of, imagine a wall that is under the ground or some kind of pin that is just holding, buttressing what you have there. So that's one option, which is using these kind of elements. Another option is if you have the space, you can literally just put a rock buttress in front, trying to contain, provide a toe and try to contain. In this case, you have like a shopping plaza next to it and a little road that passed. So it was physically not enough space. So we have to, like just put these structural elements. The moment that you start talking about structural elements, it's money, because obviously the cost of steel and all that. So we tend not to, not to go into that direction unless we are absolutely forced. Because I mean, obviously, it's our responsibility always to look out for the client, right? And make sure that we are providing them the best product that they can have, the more efficient, cost-efficient solution that they need.
Right. And maybe I should also bring out the blocks again. So the micropiles and caissons, like think about those two blocks that are sitting on each other. And we originally had that failure where gravity was allowing the top block to move along the bottom block. But with the micropiles and caissons, imagine having those two blocks there and you're pinning them together. You're literally drilling a hole down there or running like a nail or something between the blocks and pinning the blocks to each other so that there's extra force against gravity. So you don't have the top block moving. So I just wanted to say that in lay terms that way.
No, and it's great. I appreciate it because that's exactly what it is. It's a shear pin that you are putting there, so you don't depend only on the friction of the soil. So, you can put these elements vertical, like caissons, micropiles, but you can also put them in the direction of the, like perpendicular to the ground surface, which they tend to be, sometimes they tend to be more effective. In the projects that I showed you before on the previous picture, you couldn't do it like that. In this one, these are like roads that are simple. So it goes back into the process. Material cannot be taken out. This is an active road. We cannot close the road. We cannot just excavate everything out. So then we just go and start pinning it. We just start putting this, which again is the same principle that you described. In this case, it's in a circular failure rather than a plane, but it's the same principle. And then obviously I also have my son with me. That always goes to these adventures. So this is one this is funny because the picture on the left, I was working when we did the last recording, and I talk a lot about that project. So it's awesome that we now have the picture of the project almost completed with my son giving the thumbs up that everything is good. So so we put nails and we put a steel mesh basically just to connect all the nails and connect the soil and basically just hold everything, stitch it back into the slope. Obviously, these solutions also bring different issues, which is, do you have the right way to put these elements? You pray that you don't have any utilities, so you're not going to hit anything, because these elements can be 30, 50 feet long. I mean, they are long, right? They just don't go for 5 feet. So that's another solution that we have.
Okay. So soil nails, steel mesh. Just imagine you're taking the two blocks, and now you're literally but the blocks are a lot more widened, so you're putting the nails in between them, but then you're also like attaching a blanket in between those nails, a really strong blanket.
Exactly, like a really strong blanket. And it also works a little different because before, with the micropiles and the shafts, they work as shear pins, right? I mean, it's basically this. With the nails, it's different because now it works on the axial direction. It's more like now you're stitching it and kind of like pulling it. You're increasing that normal force by pulling this side or pushing that side. So the mechanism for design, instead of being pure shear, is more like an actual pull, like a force that goes perpendicular. It also has a component on shear. Depending on what country you are, like the way that I design is I either only account for the axial element or the shear, right?
Okay.
So like the micropiles and drill shafts, I only design them as shear pins. The anchors and nails and all that, I design them as axial elements. But working in projects in Colombia, Peru, Brazil, over there is different. They actually take both. And the reason that I don't know, not to criticize anything, but to me, I think there is enough research that we understand that they can work as one or the other, and it's enough evidence that it works. But I don't know if you combine the two and you assume the two benefits at the same time, if they still work the same. I think a lot of research needs to be done to confidently say that the two. So, I mean, at that point, you just start going into what the local code allows you or doesn't allow you, and try to be conservative. But if it's completely up to me, I will just use one or the other. Okay. I like to sleep good at night and not get very concerned about my project. So, it's good to stick with what you have. There you go. So
there you go. So whoever's listening or watching this, and there's an opportunity for research right there.
Yes, exactly.
Boom.
Exactly.
So let's move on here to the next one.
Yeah, so the next one is something that is also very cool because now we take all the steel out and the cost goes down, which is what if we can remove the mass that was there, right? We can take it out and then we can put something that replaces the function. So this, for example, is a road on, I think it's in New Brighton. And, basically everything failed and we have to remove it out. But then after that, we were able to come back and replace that with a geosynthetic soil slope, which is basically like, I always say, if you know Mexican food or Colombian food or any kind of South American, is the definition of a tamal. A tamal is basically the banana leaf, right? And you put like banana leaf and then the corn base and another banana leaf and you make a block and then you eat that. I mean, not the banana leaf, but you eat what is in between banana leaf.
Yeah.
But this is pretty much the same. You put a geogrid or a geosynthetic, a geotextile, whatever, and then you put some soil, right? Typically about 1.5 feet. And then you put another layer and then another one. And then at the end, what you create is a massive sandwich that is kind of like a block. And then that block can be very steep because it has so much geogrid. And then you can replace your road. In this case, we also put a facing of gabions, but the gabions really are doing nothing. It's just protecting the face. And it's really, as funny as it sounds, it's just more protecting, because when you have the geogrid and the geosynthetic kind of wrapping around, anyone can go with a pocket knife and create like a hole, and then the material could get out. Or even an animals, raccoons can go there. So sometimes it makes sense to put a facing like this so you protect it. Sometimes we don't use this, but you use, like say, baskets for vegetation. So basically, you just try to grow vegetation quickly, so it protects that face. But geosynthetics it's extremely cool. I'm actually giving a class on Wednesday in Peru about this, because in developing countries like in South America, it's great because it's a cost-efficient solution. It also, look at this way, it's very manual in the sense that you just need to lay the geogrid, lay the geosynthetic, place the material, compact by hand, and keep going. So places around the world that labor is relatively inexpensive, these solutions are really, really attractive. In a country like the US, it's different because labor here is expensive. So it may be more economical to use a machine or use concrete or a shaft or something like that than using that. So there is also considerations on that aspects. But yeah, geosynthetics is something that has revolutionized geotech in the last, I don't know, maybe 30 years, a little more. But definitely you can see the place in the last 15 in slope stabilization, because now we do a lot of this and it's great. I mean, anyone can do it. I mean, I even help friends that they want to expand their backyard, and we design little like GRS walls, geosynthetic reinforced soil walls on their property, 4 feet. You can go to Lowe's and buy a geogrid, right? So that is pretty cool in many senses. So that definitely is it's a way to fix things, creating this block. And again, the only thing that you need to make sure is that you have to take the material that is out, that failed, and what is behind you has to be stable, right? Because if it's not, then you have to put some kind of temporary wall or something. And the moment that you do that, well, now you're basically paying for two walls, one to hold temporary what is behind, and the GRS that you're putting in front. So every technique has their niche, right? And then you have to find out if it's cost effective for that. In this particular case was perfect because you have a rock, you have a rock outgroup right behind the slide. So you could literally excavate down on the slide, and the temporary stability was not a concern. It was just like a rock ledge. So yeah.
Nice. That's why you call Sebastian for somebody.
Exactly.
Yeah.
We find the right solution. Believe me, it becomes a challenge for me every time I sit to a landslide, and it's like, what could be the best way to fix this, right? And sometimes there are multiple ways to do it, right? I mean, one may be a little more cost effective, but it's not like there is only one. There is different ways.
Of course, definitely. So then this one is on Rockwall Fences.
So now we're moving into, let's say, a rock slide. So it's not the soil, but it's more like a rock slide, but it's not a block. It's more like what we defined before, the toppling, right? Like, let me just take this again. So it's something pushes and then it's come down. Or there is not really a deep-seated failure. There is not really, it's just what we call phase stability, which is maybe the rock is good enough to be cut almost vertical, but with time, little parts and little pieces are going to dislodge and are going to come down. So in those cases, sometimes it's more economical to put a barrier instead of trying to treat the entire thing. So these two pictures are very, very important for me for two different reasons. The first one on the left is right here in Pittsburgh in SR 28. And this is a place that unfortunately has killed many people, many drivers passing on SR 28, because you have differential weathering. It's the quality of the rock is good to be cut vertical, and you have a cut there that is vertical, but you have sandstone and shales, and then sandstone and shales and limestones, and every time you have those shales, they weather down with time, right? And then what happens is you have a cut like this. The sandstone phase stays always good, but the claystone and the shales start eroding and start going away. So you end up with like literally like shelves of sandstone sticking out because the support below was completely undermined. And then they fail, they break, and then it's the gigantic pieces that you can see next to me on the picture on the left. They do their best, they try to shotcrete it, try to put everything, but nature finds a way. Jurassic Park reference again. So, so things like that happen. Now, the reason that for me this is important is because I'm involved right now on a small part, but it's still involved on the project that is replacing the fence that is currently there. But the reason that it's special is because when I took that class that I was talking about, Dr. Vallejo, 21 years ago in Colombia, he talked a really long time about SR28 in Pittsburgh, and he explained rockfall and how do we design these fences and all that. So for me, remember sitting in Colombia, looking about that and looking that project in this town that was called Pittsburgh, that I have no clue what where the hell it was, and then seeing myself 21 years later fixing it one more time. It is pretty special how things come down. Yeah. So, so it's very good. And I mean, right now we work a lot with a company that's called GeoBrog. Kevin Coyle is the guy there, and they and Micropiles is another great company that also produce these meshes and fences around the world. And these products are amazing. And this is what they use on NASCAR races too, in Formula One. These are protection fences that are incredible. And what we design is we basically calculate the energy of the rocks going down and hitting the fence. And then we talk to them and we find out what is their best product to contain the rocks. And we also design the anchors that go on the ground for the brakes and to basically maintain maintain this. The picture on the right is in Vancouver, in Canada, which is one of the nerdiest trips that I have had in my life, which is we work with them a lot, and we were doing a project and we wanted to see some of the testing. So they invited me to Vancouver, which Vancouver was cool, but this was way cooler, which is, I don't know, an hour or something from Vancouver. And it's basically a testing facility they have where they take those blocks that you see like behind me, next to me. They take those gigantic rock blocks and literally throw them and see how the different attenuators and the different fences work. And this is insane because it's like, you can see the yellow tape. I mean, they obviously have like a safe zone. So you go there and spend the day just seeing these guys throwing rocks at it. They obviously instrumental this. So they also have like the computer model next to it showing like the bounces. And that's the way that they prove the product. So yeah, that trip was one of the coolest trips and that I have presence. And yeah, so it's pretty good. It's pretty good. That was the GeoBrog facility.
That's amazing.
Yeah, no, it's pretty cool stuff.
So the Rockslide is kind of the same deal as we talked about earlier with the two blocks, but then Rock Topple is kind of a little bit different, right? Because you think about like this having those two blocks, but like they're still, they could be on a surface that's not like completely flat. It could be a little inclined, but really you think about it like you have one block and then the other block's like just at the right spot where it could teeter a little bit. And it comes down to really just the center of gravity of the top block, right? And any influence on that, it could be erosion through weathering, or it could be a seismic event. All it has to do, it could be just vibrations from roads, and over time that center of gravity can move out to where you get to a tipping point. You have a moment, and the overturning moment is too great and it ends up toppling. That's what it's called.
Exactly that. It's just the center of mass moving little left in that case from the normal, right? And boom, then it just goes. It's you trying to push your friend into the pool, right? And then your friend trying to maintain equilibrium until one point that it's gone.
Absolutely.
And then the fence is catching it.
Right. That fence, I've driven past that fence a few times, and I love actually just looking at the design of the fence. I think it's so cool. It's like, so for people that aren't seeing this, it's like there's like circular, there's like, it's like steel circles that are intertwined with each other. And man, I would love to see that simulation.
No, it is awesome also because it's a lot of engineering. As I say, GeoBrog and Micropiles, both companies have put decades, if not centuries, of research on that. And and for me, I have attended many courses on that. on the design of that. The philosophy also changed a lot in the last like 20 years. Before, when you talk about a Rockwall fence, you try to create like a very rigid and stiff element that was containing, right? So it's basically, imagine doing a wall that basically when the rocks fall, they contain it. But then also what they realize is that that's not the way. It's the same as like seismic engineering. Trying to be stiff and contain things is never the answer, because there's always going to be more energy coming down. But the trick is more to dissipate that energy. So now these Rockwall fences, they have all kind of pivots and what I was calling the brakes, which is when they move, then they have these anchors holding back. And those circles that you see on the cable itself is the brake. They kind of just stretch, right? And when they stretch, what they do is they dissipate the energy. And the idea is that if you have a big event, it's going to ruin the fence, but that's fine. You can replace the fence, right? But the idea is that it stretches in the form and it absorbs all the energy. And they tend to be better than just having a rigid system. So it's the same thing on earthquake engineering. When you design foundations or structures, you don't want to have a rigid structure. You want to have the one that flexes and dissipates energy rather than accumulating and fighting. So no, I mean these are professionals that dedicate their lives to design of these things, and that's what I said. I mean, like I was there for like 3 days, and it's like a nerd vacation on steroids, because you go to Vancouver, they give you like 2 days of classes of just the design and all that. And then you go at the end and they teach you these fences and all that. So yeah, I came back with a smile on my face and 3 ring binders of, how to design that.
So, okay. So engineer, quick taking a look at this, right? So I'm imagining the rock toppling and hitting the midpoint of the fence, right? In between the posts. So my thought process is you're going to see a concentric dissipation towards the posts. The posts are going to eat it, and it's going to transfer towards the cables. The cables will eat it, and then they'll transfer right to the anchors. So am I saying that I'm thinking that the anchors would probably take a brunt of that, because that's where a lot of the energy is traveling towards.
Correct. And really the anchor is the one that says like no more, right? I mean, all the system is dissipating energy, and that's the reason the brake has that circle, because it's basically, that circle is, when you tie it, the circle disappears, right? It just gets tied.
Oh, I see the circles. Yes. Okay.
Yeah. So that's what is called the brake. The circle just disappears. It's like if you're tying your shoe, it just dissipates. But the anchor has to be strong enough, and that's the part that I designed. Is those anchors going on the ground and making sure that you have enough resistance that then the anchor doesn't just pull out, right? So because the brake doesn't work, if the anchor doesn't pull back, the brake doesn't work. The brake then just goes and everything flies into the road. So yeah, it is super cool to work those together, and and it's great. I mean, fortunately, we have great companies like Geo, Rock, and McAfee that it's easy to work with them, and then we can do this solution as a team, because obviously, the part that I designed with a software that is called the Colorado Rockfall Simulation Program, or CRISP. What we do is that we simulate these particles coming down, and we find out what's the energy that they have when they hit the barrier. And then we work with these companies to find out what the barrier that we need. And then they gave us the force on those cables. And then we designed the anchors to withstand those forces. So it's a very cool product, and it's awesome, man. And every time that I pass next to 28, I feel way more safer knowing that we designed those anchors.
Heck yeah, you're saving lives for sure.
Exactly, absolutely.
So the last portion of segment 3, I was interested in getting some of your knowledge on. I know we talked about remediation and prevention. Another portion of prevention is instrumentation and monitoring. You spoke a little bit about that at the beginning of the show, but I'm just kind of curious, what comes off the top of your mind in terms of like companies, or maybe even your company, like what they do in terms of just monitoring?
No. So we do a lot of that. We do a lot of that because typically the first step when you feel that you have a landslide or you see some signs, but it's moving slowly, it's to try to instrument. So there is couple tools that we can use. Inclinometers, they are called, is basically, let me just get a pen here. So an inclinometer is basically you make a hole on the rock or the soil and you put the instrument, right?
Yep.
And then what you do is that you monitor how that is deforming. Before, we used to do it by hand, in the sense that we make a hole on the ground, we put some casing, and we go with something that is called a torpedo, and then we lower it and put it up, and then rotate it and do the same. And that thing kind of has a memory and shows you the profile. These days, all this has been revolutionized in the last 10 years, and now it's all in-place instrumentation. So it's basically you put this, and it's a rod with sensors, right? And they have accelerometers. So when they move in any direction, it could be 3D, right? They will tell you how much they move. And that also brings us into the other one that is called extensometers, which is another road similar, but now if it's moving down, this is also showing you if it's compressing or not. So now I have been witnessing that revolution, because when I started, I used to go with an inclinometer and then lower the torpedo, put it up, go to the office, download the data. Now it's all in place. There is great companies around in the Pittsburgh region. You have many. I work with many, so it's not like I have favorites, but I would say that all of them are my favorite. You have Geocon, you also have Rock Test, you have Meli, my good friend with Right Geosystems, and there is plenty of different companies that offer this, and the price keeps going down and down and down. So it also allows us to instrument projects. I mean, right now I have one slope stabilization that we basically are monitoring, and it's been 2 years and a half. And at any point, I can just go to the website, log in, and see the data in the last hour, right? I mean, it's insane. And it has all kind of settings, for like alarms and things like that. If the movement like start accelerating, you get a text message on your phone. So, and I mean, obviously, the more that we can instrument, the better, right? Because it helps us studying them to establish. I mean, that's the way that you also find where is the failure plane. When you put an inclinometer, you see where something is moving until one point that is not. So that means that right there is your failure plane. And then you can plot many of these if you put them on cross section, and you have your model right there showing you where it is. So they're important for investigation, but sometimes they're also important after construction, right? Because you also want to monitor and make sure that things are working properly. So I mean, obviously it's a cost that has to be taken by the owner, and it's an extra product that we always try to bring and say there is value on this. I think, obviously it's not for every single project, but for the ones that is worth it, we always try to show that and say it is worth it that you think on that. And as I said, I mean, the cost is just because the technology just keep advancing. It's gonna sound funny, but I don't know how many people are in the market of accelerometers, but the cost of an accelerometer, if you look the last 20 years, have dropped. I mean, it's something that was very, very specific before. Now you can buy it on the internet for no money almost. So, so that's good for the profession, because the more instrumentation, I mean, information is the key. The more information you can have, the better. The more borings you can have, the better. The more geophysics, the more instrumentation, the more everything. So as all these keep being more accessible, I'm sure we can understand better the problems and we solve them better, right? The more we know about it.
Absolutely. Yeah. I've actually had a few spins at strain gauges in my short lifetime.
Yeah.
I spent a whole semester doing a project. Pierre Vincenzo Rizzo. Have you ever met him?
Oh,
yeah. He's a great professor. I had him for structural health monitoring, and I looked at data from a bridge, like for 2 years worth of data. And I was trying to figure out what was going on. Why were we seeing excess amounts of vibrations in the roadway or from the bridge? That was really cool.
He's doing a lot of cool research, and Dr. Harris also doing a lot of cool research at Pitt. But just to show you how old I am, man, I was at Pitt when both of them, Dr. Harris and Dr. Rizzo, interviewed. I mean, they were almost. I mean, well, no, I think Dr. Harris already was teaching before, but I think Dr. Rizzo he just graduated, and my last semester it was his interview, and I remember like watching, because that's the way that they interview the professors and the grad students kind of get to see it, and I guess they also get a feeling if people are interested in the research. And I remember watching him, and I was like, man, he's working a lot of cool stuff, and I was like almost out at Pitt, right? I was in my last semester, so I remember thinking like, man, I wish I could have seen a little more of what he's doing. But so now he probably has been there for, I don't know, like 16, 17 years. He's already like associate professor, and yes,
he's doing great. Yeah. Strain gauges are really, like you said, accelerometers. I call them strain gauges. They're same thing, but yeah, they're everywhere. I mean, they're in our phones. They're in literally in the soil. They're around bridges. They're everywhere. Just trying to monitoring. Just little deformations. Like if you get a little anywhere where there's a force, you get a deformation. It takes real-time data. It puts it in a log, and then you get to see it over time. It's pretty cool. Yeah, really cool stuff. And yeah, like you said, I mean, the future's bright. The more information that you get, the faster we can detect landslides, maybe predict when they're going to happen, and also understand a lot of the parameters behind the site. So whenever you get there, you can hit the ground running and get get people like you out there to say, all right, we need to do this type of remediation because this is what's best. We have all the data. It's telling us this. Let's go do it. Here's the cost. Let's go.
Yes, exactly.
Yeah.
Exactly.
Boots on the ground. So Sebastian, this was great. I really appreciate you coming back onto the show and talking about landslides.
Now it's gonna be our annual tradition, right? We pick a topic once a year and then we get together and talk the heck out of it. So
yeah, it sounds great. I mean, you're such a busy man. It's great to have you back on the show, and it's always great to hear from you. Always great to hear the updates, and you just keep grabbing these awards. I think Dr. Vallejo is definitely proud of you, man. Definitely proud.
Yeah, no. Thank you. I mean, it's always that I love what I do. I always did the same way that you do, right? So it's awesome to be involved on many professional societies, and I mean, obviously the awards are great to get them. I mean, it's a recognition. When you get recognition by your peers, it's great. It kind of validate a lot of the sacrifices and efforts that you do. Obviously you never have to let them go to your head, but it is amazing. I mean, it's really a good feeling, and it's all good. And I'm very happy that that we did this. As I said at the beginning, I hope that somebody is listening to this and get excited on landslides the same way that I got excited when I met Dr. Vallejo and kind of fell in love with the field of landslide stabilization. And I think it's something cool that obviously you also were a student 2 decades after I was a student with him, so or you kind of knew him from Pitt, and it's great that we can do a little tribute to a great guy and a great person, for everything that he did for us. So I'm very happy that we keep this as a testimony and pretty cool stuff, man. And the pictures are awesome too. So great that we have it now on video. So
yeah, thanks so much. Thank you so much, Sebastian. It was
all
great.
right, man. We'll be in touch.
Thanks.
Bye.
That is all for this episode of Everything Steam. Now I'd like to give a big shout out to Sebastian for coming back onto the show and sharing his knowledge and vast expertise. I would also love to mention my amazing team for their collective efforts to make this show happen. This podcast was edited by myself, marketed by Courtney Page and Maria Pusateri, QC'd by Panyapit Urixit, and our episode art was manifested by Gabrielle Edmiston. After the episode, please give our podcast a rating and review on whatever platform you get your podcasts on. We're always looking for feedback, and the rating would greatly help us out in the fight against the algorithms. Also, we just kicked off our bi-weekly newsletter where we plan to preview the episode release of that week by giving out some facts from the recording as well as some things that we missed during the discussion. And here's the cool tidbit. You'll be able to reply to our newsletter with a question for the upcoming show. Moving forward, we will take 1 to 2 questions from our audience and attempt to address them during the show. And lastly, be sure to check us out on all the socials for podcast news, upcoming episodes, and fun Steam content. Just search Everything Steam on Instagram, TikTok, Facebook, and Reddit to join in on the fun. Once again, thank you for listening to Everything Steam. I'm your host, Sam Stanford, and as always, stay curious.